So the first question on the test is decide whether the function represents growth or decay. So remember we looked just here, right? That's a factor. Not this a value, only this. And so you would say it's growth, and you would go like this. You would show your work. You'd say 2 is greater than 1, so growth. Because they ask why. Then what is the y-intercept? The y-intercept is when x equals 0. So I'll plug it in. That'd be, you show your work, 4 times 2 raised to the 0, which is 4 times 1, right? So then we plugged in 0, got out 4. You have to write it as an xy point, x, y. We plugged in 0 for x and got out 4. That's how you write the y-intercept. Then it says sketch the graph, so I'm letting you use your calculator, so you would just show your xy points. You would draw it in, and then you would make sure to draw in your asymptote. So these are the points I'm going to hopefully want to see, like -2, -1, 0, 1, 2. You know what I mean? Just type it into your calculator, and then whatever you get out. And then see how this one has no shift up or down, no shift left or right? That exponential function will have an asymptote at 0. So to get full points, you have to draw in the asymptote at 0. And then it's exponential growth, so it looks something like that. But you will be exact on the test. You guys know how to type it into your calculator? Okay. So you're just plotting points. But you have to draw in the asymptote. Okay, this one wasn't on the review, but it is on the test. So everybody, it says, decide if the function is growth or decay, and how do you know? So we only look at this value, right? A fourth. So you would go like this to show your work. A fourth is less than 1, so that's decay. And then what is the y-intercept? That's when x equals 0, so you show your work. So that's 3 times 1/4 raised to the 0 minus 2. So that's, yep, 3 minus 2, which is 1, so you have to write it as an xy point, xy, so that's, you plugged in 0, got out 1. And then it says sketch the graph. So once again, your xy points. What I want you to notice is on this one, there's a shift of down 2. So instead of having the asymptote at 0, there's a shift, it's at -2. You have to draw in the asymptote to get it fully right. Because I had people, you know how to type it into your calculator, 3 times the 4th raised to the x, and then you get out of the exponent -2. So you plot some points, you know what I mean, whatever they are, and then they didn't draw in the asymptote, so they just got some marked off. Does that make sense, everybody? So this one was decay. It looks something like this, and it's going to approach and get close to the asymptote. I'm just trying rough sketches because I feel like we all know how to put things in. Any questions about it? Okay, it says, okay, the number 3 on the test says compare the graphs to the graph, compare the equation to the graph below, which one has the correct equation. So I just look at the equation, okay? So let's look at this. Let's look at the shifts. Isn't that left 5? Left 5 and then down 3. So our asymptote should be at -3 because it's exponential. So it should be at -3. So we definitely know it's not that one, right? So it would be this one and y because the asymptote's at the correct spot. And look, it shifted left 5 down 3. Does everybody get what I'm saying? So that one should be easy. I don't think anybody's missed that one on the test so far. Okay, it says on number 4 and 5, it says rewrite each equation in exponential form. So right now it's in log form, and notice that we're not solving because it's already solved. Like we have an equal sign that equals 2. Rewriting it as an exponential. So log to the base 12, to write it as an exponential is base 12. So you would write on the test, 12 squared equals 144. And how do you know you got it right? Because it's a true statement. I had people write 2 to the 12th equals 10. It's like, no, look at your problem. Like, that is not true. Like, you know you did something wrong. Does that make sense? I'm just saying, like, that was a dumb example. But you get what I'm saying, everybody. Like, 3 to the 10th equals 9. And you know what I mean? Weird things. I'm like, what the heck? Okay. So that's a true statement. We didn't have to solve anything. It was already solved. So this one is log to the base what? So secretly write in the 10, and now we rewrite it as an exponential. So I'm doing log to the base 10. You'd base 10 both sides. That under that. So 10 equals 10 to the first. So we know we did it right because it's a true statement. Those are easy. That's number 4 and 5 on the side. Okay, 6 and 7 are going the other way. Write each in logarithmic form. Notice they're already solved. So we need to undo base 4. So we would log base 4 both sides. And I want to see it look like this. Those cancel out, so 2 drops down. So we have log to the base 4 of 16. right? So this is easy. Log base 3, log base 3, ding ding. Negative 2 equals log to the base 3 of 1 minus. So that's 6 and 7. Okay, the next part of the test says evaluate each expression. So you can, that means solve it, right? You can either write it as an exponential or solve it by change your base formula. I don't care as long as you can solve it correctly. So looking at this one, if you tried to solve it as an exponential, you'd base 4 both sides, right? So 10 equals 4 to what power? Nothing, correct? So we're like, no, we're not going to solve that way. Does that make sense? So we're going to do the change your base formula. So that would be log of 10 divided by log of 4. Any questions on that? And then you type it into your calculator and do a few decimal places. Or if you can change it back to a fraction, that would be good too. Okay, so let's look at this one though. Do you see how this one, if we set it equal to x, we base 2 both sides. So that one does that. 1/8 equals 2 to what power? So 2 to the first is 2. 2 squared is 4. 2 to the third is 8, right? So -3. Everybody see how I did that? So -3 was our answer. These ones you should be able to do without even using your calculator. Ln and E, aren't they inverses of each other? So 10. Base 5 raised to the log base 5 of 14x. 14x, guys, base and log to the base 5 times log. So those ones should be doable without a calculator. Everybody good? Okay. So that doesn't mean because I had people then set that equal to 0 and solve. No, it says evaluate, which means simplify. So that's simplify. Does that make sense? So don't do that. Don't solve it. Like, this one's just simplify. Okay. Next one is graph the log equation. So this is what you're going to do. Instead of look like, we don't know how your calculator won't do it for you. You can't come up with XY points for log very easily. So what you're going to do is rewrite it as an exponential. So that would be switch x and y, right? Find the inverse. Log the base 5 of y. Undo base 5. Log the base 5. So base 5 to both sides. So now y equals 5 to the x power. Those points are really easy because we can do them in our head. -2, -1, 0, 1, and 2. If we plug in -2, that's 5 raised to the -2. That flips over a fraction. 1 over 25, right? 5 to the -1 is 1/5. 0 is 1. If you plug in 1, you get 5. If you plug in 2, you get 25. Now you don't want to plot those points because that would be plotting the exponential. We're not graphing the exponential. We're graphing the log, which is the inverse of those points. So just switch x and y. So you write out x, y. You put this first, 125. 1 over 25, -2. You're going over a fifth, down 1. You're going over 0, up 1. You're going over 1, up 0. You're right. And then over 5, up 1. Over 25, up 2. So you would graph these points. So look how that would work. You're going over barely any, because that's what 1 over 25 means, almost barely like 0, right? Then down 2. Going over a fifth, which is a little bit more, down 1. Going over 1 up 0, over 2, no, over 5 up 1, over 25 up 2. So you see how it's going like this, everybody? That's what logs look like. They're non-shifted. So then we should draw in, I don't think anybody drew in, actually like one person. Logs have an asymptote like this at 0. Remember how exponentials had one like this at 0? Logs have one right there at 0. Everybody comfortable with that? Okay. So you would just instead write it as an exponential, figure out those points, but then switch them. Then plot it and then draw your asymptote. Okay, so our domain is 0 to infinity, isn't it? Not including 0. Our range is going down forever, up forever, so all real numbers. For a log. Okay, it says expand each completely. I think this is too easy on the test. Expand each completely. So when you add, you multiply, right? When you multiply, you add. Okay, when you divide, then you subtract. So this would be log of x plus log of y plus log of z minus 2 log of a. Does everybody see how they just took the 2 down automatically? Okay, good. That would be how you write that one. So this one, it would be ln of e to the 1/2, right? E to the 1/2. Then plus, and then that would come in front, right? Is anybody confused on why I did that? Plus 3 ln of x, right? The 3 came down in front, minus ln of b. Then you have to say, does it simplify? This is what people are missing. They're able to do this, but then they're not simplifying. What about ln and e? They cancel out, don't they? Isn't that what inverses do? So we just have 1/2 plus 3 ln of x. They don't undo each other. Minus ln, that's an ln of b. That would be our final answer here. Questions? Watch out for that. Okay, so expand each completely. So we just did expand. We don't need to do more, I don't think. Well, here's one thing I want you to know. These aren't connected, right? This would be its own log. Any questions on that? Okay, what about this one? ln of e to the x. So let's just maybe do this one. So that was ln of e to the x plus 3 ln of a, right? Minus ln of 2. Now, do any of those simplify? Oh, that again. So doesn't x drop down? Okay, just make sure you do that, if possible. Okay, so it says write as a single logarithm. This will be 15 on the test. So when you subtract and you divide, so this would be log to the base 3 of 9 divided by 27. You would show your work, which equals log to the base 3 of 1/3, which you can now simplify that one more step, right? Because can't you do the change of base formula? Or can't you think of it like this? Log to the base 3 of 3 to the negative 1. Isn't that 1/3? So don't those cancel out? So isn't our final answer -1 in this case? You could also just type it into your calculator. Log of 1/3 divided by log of 3, and it will give you -1. It's just 2 different ways to simplify it. Okay, so with this one, we have to fix our exponents first. That's what I'm seeing people mess up on. This 3 in front is really an exponent. So we have log of 2 times 4 to the 3rd power. So then that's log of, I don't know, 4 to the 3rd power times 2. Anybody have their calculator out? I don't have mine out, no? You did that in your head? What's 4 to
4 cubed is 64, and then 64 times 2.
Oh yeah, good job. You're right. 64 times 2. Yep. So that would be log of, and then you would actually keep going with that on the test.
Yeah.
Because then you can just type it in. You see how it's base 10?
Yeah.
So log of 128, everybody? Okay, awesome. So whatever that decimal is. But write out both on the test. You know what I mean? Showing your work never hurts. Okay, write as a single logarithm and simplify. This is what I'm seeing people forget to do. They're able to write it as a single logarithm, but they're not simplifying. So look at this one. Log to the base 4 of both of those 2 and x all cubed. All over divided by 4y. Because when you subtract, you divide. That simplifies, but 2 and 4 don't divide them right now because that'd be wrong. It's 2 to the 3rd power. So isn't this really log to the base 4 of 8x cubed? Over 4y, and now you would simplify. People are stopping here on the test. So then that's log to the base 4 of 2, because those divide out, right? X cubed over y. That would be your final answer. People aren't simplifying on the test. So same thing here. You pull this up, bing bing, this up, and then you would distribute it through and then simplify. Pretty easy. Okay, this is the part of the test where it says, no, this is the calculator portion, but I'm letting you use your calculator for all of it. So it says, how long does it take the principal of 2,000 at a simple interest rate of 10% become 5,000? So it does not say anything about compounding continuous, right? So you would use this equation. Y is equal to a times b raised to the x. So this is the amount in the end. So how much do we have in the end? 5,000, right? The amount to begin with was 2,000. We don't know, oh, it says at a simple interest rate of 10%. So wouldn't that be 1.10 raised to the x? And now we can solve it either by graphing or by algebra. Let's just do algebra because it's quick. To me, it's easier. So we isolate the base, so divide by 2,000. Divide by 2,000. Then when we take, so we have 5 over 2, that's what that would simplify to be, equals 1.10 raised to the x. So now won't we log to the base 1.10 of both sides to bring this down? Log to the base 1.10. And now you have to do, change your base formula, so it's going to be this. Log of 5/2 divided by log of 1.10 equals x. So then you can say on the test, So I'm marking this for a second. Log. So on the test, you would just say, like for example, it will say on the test round to the nearest whole year. So let's say it was 2.6 years. If you would say 3 years, right? About 3 years, because it says on the test to round to the nearest whole year. Does that make sense? Okay. So next one, you invest $200 in a bank account that compounds annually. That means just simple interest, not compounding continuous. Your friend invests the same amount that compounds continuously. Both bank accounts earn 7% interest. So it says after 5 years, who has more money? So this is how you'd be showing your work. You would do y is equal to 500 and then 1.07 interest, right? Raised to the 5 years. Because you just got simple interest. But your friend got compounded continuous. So you go like this. Friend uses purge. So y is equal to p is the put down amount, 500, e is just the x, is just a number, right? And then raised to the RT. Now you don't for purge change the percent, so 0.07 times 5. So you type it into your calculator, so you have this much, your friend has this much, who has more? You say, yeah. Right here, oh, sorry, it was 200. Sorry, this is 200. Sorry, I'm going so quick because we're starting on my face. Sorry, does that make sense, everybody? So then you would compare, and then it says on B, who made more money? So you'd say you or your friend, depending on who's come out more. And then it says how much more. So when you just take the larger, subtract the smaller. So like $8 or whatever. Okay, it says an earthquake of magnitude 8.2 was compared to an earthquake of magnitude 7. How much more intense was earthquake 1? Now on the test, I'm telling you right now, when you compare your earthquake magnitudes, it's going to come out not negative. So if you do and it comes out negative, switch them. As in, like, you put this one first, the wrong one first. Because on the test, it's kind of confusing of which one am I putting as earthquake 1. Does that make sense? So I'll give you the equation. So it's log of I1 divided by I2 equals M1 minus M2. So we have log of I1 divided by I2 equals, I'm going to do the big minus the small, 8.2 minus 7. So log of I1 divided by I2 equals, no, yes, 1.2. No, yeah, it's not 1.2. 1.8. No, let's see. 8. How do you get from 7 to 8.8? That is 1.2. We're just thinking too hard about it. We're thinking too hard about it. So then what do we, this is where people stop on the test. That's not right though, right? Yeah. Base 10 both sides. So it's 10 raised to the 1.2. And then whatever that is how much more intense. Does that make sense, everybody? Because then you'd multiply up I2. So that much more intense. Does that make sense, everybody? Yeah. Really straightforward. So like, if it was 5,323 times more intense, for example.
How did you guys get 1.8?
We were thinking too hard about it. Because 2 is a way to
I
think.
said 1.2.
I'm bad. I was subtraction. I always overthink it. Hey, yes. Yeah.
Should we just like
Actually move the decimal. Yeah, move the decimal. Good question. Okay, this next part says use a calculator to approximate to the nearest hundredth. So let's just change your base formula again, right? Log of 2 or log of 7. Everybody, okay. So next thing it says solve each equation. So isolate e. So you subtract 4, subtract 4. Negative e raised to the 2x equals 6. Divide by negative 1. So I'm going to make this negative 6 because it needs to come out. It's anyways. E to the 2x equals positive 6. Because we have to divide by negative 1. Does that make sense? So then wouldn't we undo e with ln? So that undoes that. So we have 2x equals ln of 6. And then you would divide by 2. So on the test, you're going to show that answer and the decimal answer. Okay. Next one. Solve each equation. We have 2 ln's, so we need to put the ln's together using properties of logs. Wouldn't you multiply those? So 20x, ln of 20x equals 4. And now because you put the ln's together, you can undo ln. So you e both sides. So 20x equals e to the 4th power. Divide by 20, divide by 20. And that's the answer you'd show me and the decimal. Does that make sense? Okay. Solve each equation. Log. We're good. So how do we undo this log? Base 10 both sides, because that's log of the base 10. So that undoes that. So 2x minus 5 equals, that undoes that, equals 3x. And then you should know how to solve that. What do we do? Subtract 2, right? It's linear at this point. So that means negative 5 equals x. So that's our answer. Solve each equation. So we would subtract 5. So we have e raised to the 2x minus 4 equals 12, 11, 10, 9, 8, 7. And then when we divide by 2, leave it as 7 halves, guys. Then we would ln both sides. Ln undoes e, so 2x minus 4 equals ln of 7 halves. Then we would add 4, right? Then divide by 2. So you'd show that and then type it in. Here's the key thing. Make sure you hit that, enter in your calculator, then divide it by 2. Solve each equation. So looking at this one, couldn't we log base 9 both sides? So now we have 2x plus 3 equals, well, we need to change the base formula. So that'll be log of 2187 divided by log of 9, right? Change your base formula. And subtract 3, right? Divide all of that by 2. That would be how we would do that one. I had so many people miss that one on the test. Okay, this next one's a little bit trickier because we can't do that log of the base 64 of both sides. Then we're in problems. So we would have to get them in terms of the same base. So for example, 2 to the what power equals 64. Then make this the same base. So 2 to the what power equals that. And why do I choose 2? I just randomly chose. So like I tried 8. 8 squared 64, but 8 to nothing equals that. So I'm like, it's not base 8. Does that make sense, everybody? So then I tried, is there any, like 2 to the what power equals 64? And so then it worked, and so then I did this. Does that make sense? I don't remember. I need a calculator to hurry and figure it out. But you get how it's just trial and error. So I start with the smallest base. So like I said, like 4 to the third power, 4 to the third power is 64. So then 4 to the fifth power, oh, it was 4. So this is 4 to the third power raised to the 2x equals 4 to the fifth power raised to the 3x minus 1. So I just tested it. It's just trial and error. So then that's really 4 to the 6x, right? Now this is where people are messing up. It's 5 times all of that. So that would be 15x minus 5. So 4 to the 15x, they forget to distribute, minus 5. So now we would log base 4 both sides. So now that undoes that, that undoes that. So our equation is now linear. 6x equals 15x minus 5. So combine your x's and solve. Does everybody get what I'm saying? All right, a student wants to save $12,000 for a new car. How much will need to be put into account that pays 10% annual interest, compounded continuous? The keyword is compounded continuous. Assume that it takes them 5 years to purchase the car. So it says the student wants $12,000. So that's in the end, guys. In the end, they want $12,000. It says how much are they going to put down? So we don't know P. E is just a number. Our interest rate is 10%, 0.10. And then it says assume it takes them 5 years. So then it's just literally algebra because that's just a number, right? So just divide by E, 0.10 times 5. Divide by E, 0.0 times 5. Because now look, P is a loan and that's how much you had to put down. So it should be less than 12,000, right? Everybody get what I'm saying? Okay, it says find the inverse of the function. This is the last problem on the test. How do we find inverses? We switch x and y. So log the base 3 of y minus 4 plus 2. Then what should we do? Subtract 2, right? X minus 2 equals log to the base 3 of y minus 4. Now our next step is to undo log to the base 3 because y and 4 are trapped inside base 3 both sides. 3 to the x minus 2 equals y minus 4, and then when we add 4. 3x minus 2 and then plus 4 equals y. And that's the inverse, guys. It's that easy. It's just algebra. Any questions? We went really quick through that because we started late for the meeting. So I apologize. So that's everything. Very straightforward test, right? We don't need to like